So unfortunately, Wednesday's lecture, as soon as I stopped it and tried to submit it, I got a little error message that came up and said, an error occurred, or we can't submit your lecture. Now, a lot of times when I get an error message, Tech Relay will actually attempt to recover whatever it can from that recording. I didn't get anything this time. I came in early this morning to see if I could maybe figure out how to recover it as well. Couldn't figure it out. Now, so I can't actually promise that today's lecture will work either. Okay? So I'm going to continue to try to record these. I've told Jared about it, so I don't know what else to do other than, if they don't record, there's certainly going to be some overlap between what I'm doing for you guys this semester and what I've done in past semesters. Unfortunately, they probably aren't going to line up lecture for lecture, but overall, the general gist of the material is covered in the previous recordings. So you always have that as a backup, try to figure out based on the title roughly where that would correspond to in a previous lecture, in a previous semester. So I don't know what else to tell you. If that persists, I don't know, there's not much I can do about it except continue to tell Jared that there's a problem with Tech Relay. I don't have any issues in 206. I teach in there 3 times a day. And here, Monday, Wednesday, Friday, I've got 3 classes in there and 1 in here. And I haven't had any issues with that one. It's worked just fine. In fact, for the previous portion of the semester, I had no trouble in here either. So I apologize in advance. It could very well happen again. I don't know. But we'll press on with today's lecture, and I want to start by talking about arrays some, and then enumerations, which I believe you need for your next lab. So sometime between today's lecture and Monday's, I've got to finish that material as well. I don't think arrays will come as any surprise. Probably for most of you, it's going to be pretty trivial stuff, not substantially different than what you did in C++. But nevertheless, I'll spend a couple of slides here on arrays. And some of you have already actually finished the lab. Of course, the Tuesday group is due today. So you had to use some arrays in that context as well. But just for completeness, I'll go ahead and cover arrays. I doubt that you guys actually need me to do this, but we'll go ahead and do it anyway. Okay, so if I want to create an array of primitives, that, just like you're used to in C++ when you create arrays of objects that aren't pointers versus objects that are, the same kind of rules apply in Java. The only things that are not going to be pointers, however, are primitives like integers, characters, booleans, floats, that kind of stuff. Any type of object, you don't have a choice. It's going to be the array is going to be filled with pointers. Okay, so let me give you a couple of examples and draw pictures to hopefully remind you how this works. So if I want to create an integer array, here's the syntax for it. Suppose I wanted to store 66 random numbers like you're doing in your lab. Okay? Arrays themselves are always objects. So an array, I'm always going to be using the keyword new with it. And I'm going to be specifying the number of elements I want to be created in there. In this case, 66. So my array indices I know are going to run from 0 to 65 because arrays are 0-based. Okay? So what I can expect to happen in memory is have, integer 1, integer 2, all the way up to integer 66 stored in that array, and I'm going to have a pointer to it, my array, because remember the new keyword returns an address, and I'm simply going to store that address in the myArray pointer variable, and it's going to store the address of the first index of the array. Okay? Probably no big surprise there. So we can jump around inside that array really quickly if we know the starting address, the first index of the array, and we know the size of all the compartments in there. And of course, depending upon whether we use an integer or a long or a short or a byte, I don't generally in this class worry about all those other types. We use integers, floats, doubles, characters, booleans, that's it. Okay? We're not going to worry about all the more exotic, really short types. that you probably discussed in 2100. Won't bother with that kind of stuff in here. We use integers, and every once in a while we'll need a long. Okay? All right, so integers, of course, have a fixed size. So I can jump around to any integer inside this array really quickly if I know the requested index, I know the size of each of the items that's stored in the array, and I know the address of the first index. Okay, so I've got a multiplication and addition that I need to perform. Those are done really quickly. So I have access to any of the integers is really fast, and that's why ArrayList is a good choice. If you're not exactly sure what type of data structure you need, an ArrayList simply uses an array behind the scenes, and it takes advantage of the fact that you can jump around to each index very quickly. Okay? The vast majority of the time, we're probably not going to be using primitive arrays like this one. We're going to be more concerned with object arrays. Okay, so suppose that we have what rational number. Let's make a rational number array. Okay, something we discussed in class. And we'll have 66 of those too. Okay? Looks the same. The primary difference being I'm using a class name to declare this array rather than a name of a primitive. And so Java is going to realize that the model it's going to use to construct that array is going to be different. The size of the elements in the array are not going to depend on the size of the underlying primitive, like integer, short, float, double, that kind of stuff, which all potentially have different sizes. All of these types of arrays are going to have the exact same size, and that's the size of a memory address, 32-bit, 64-bit, whatever the case may be. Okay? So it's going to be an array of pointers. So we're just going to have a bunch of memory addresses that presumably contain the address of some rational numbers, which contain numerators and denominators. So we might have 1/2, 3/4, 7/8, whatever. Okay? However, the way that these arrays are initialized is different than what you're probably used to from C++. If I create an array of integers and I haven't actually put any integers in there, Java's going to be nice and initialize that array to contain all zeros for me. If I create a double array and I haven't placed any doubles in there, it's going to contain 0.0. Okay? What do you suppose it's going to put in there if I haven't actually created any rational numbers yet and I try to create a rational number array?
Null.
Null. The whole thing's going to be full of nulls. So a very common mistake, let me redraw that rats on this page. When you're dealing with an array of objects, is to forget to actually go through there and put the objects in the array. Okay? So initially the thing is going to be full of nulls. And if you try to access something in there, like rational number R1 is equal to rats of 32, R1 dot get numerator. And we'll store it in a variable v. Okay? If I try to do something like that, this first line is going to work just fine. We're going to go to the index 32 of our array, and we're going to copy null into the pointer R1. Okay? We only have an issue when we try to call a method on null. Calling a method on null is how you get a null pointer exception. Okay? So what you're going to get used to, I've already seen a whole bunch of these, in fact a couple of cases. I said that these usually get pretty easy to find and fix. Well, on lab 2 there was a couple of you that brought null pointer exceptions to me. It took me a while to figure out what the problem was. But one technique that usually helps is look around where that error was generated and print out the contents of the objects. One of them is going to be null. Okay, and then you need to figure out, well, why is that one null, and that leads to you successfully debugging that error. Okay, so I can still say with confidence that majority of cases they're going to get easy for you to figure out. Okay, but not all. Sometimes it's a subtle error and it takes some work to debug it. Okay, so we got to go through there and populate the if we create an object array, we've got to populate the array with objects. Okay, now an array list, of course, whenever I call the add method on the array list, what you're essentially doing is that. Okay, and you guys remember array lists, they grow and shrink depending upon whether you filled up the array or not. Okay, so they dynamically resize themselves. So that's what's nice about using an array list over a regular old array. That's not going to resize itself, so if you need a different size, you've got to create a new array of bigger size, copy all the old objects into the new one, and then put the new stuff in there. Okay, it's convenient to have array lists do all that stuff for you. Okay. There was something else I wanted to say, and now I've forgotten what it was. Does anybody know what it was? Hopefully it'll come to me. Nope, it's gone. All right. So the way. Oh no. Yes. Okay. Think. Don't lose track. What if I want to use a for each loop on an array? Okay. It might look something like this. I've declared that same array rats on the previous slide, and now I want to use a for each loop to visit all the elements in it. Okay? Very common thing to want to do. As I'm going to explain, this works a lot better for array list than it does for an actual array. So we've got that array of rational numbers, and suppose that I want to do, get the numerator or something silly. For whatever reason, I want to print out the numerators of all my rational numbers because I've got nothing better to do that day. Okay? If it's in an array, you should be careful about using for each because it's going to hit all the elements in the array whether they have something in them or not. So most of the time, it's probably the case that when you want to create an array rather than using an array list or something like that, when you create an array, your intention is, especially if it's an object array, you're going to fill it up with stuff. Okay? But in the somewhat unlikely event that you've got part of the array has objects in it, and you just had too much space, and so some of it's got nulls in it, you are going to get a null pointer exception if you try to use the for each loop. Okay? Because it's going to want to visit each and every index in that array, which includes the ones that have nulls. Now, an array list, so if rats is an array list and not an array list is a class. It's got stuff in there that's designed to handle that case. It's only going to loop through the part of the array that contains actual data, and it's going to ignore the rest. So you expect an array list, because it's dynamically resizing, it's highly likely to have an unused section. Okay? So it's smart enough to not visit those elements if you use a for each statement. So you probably won't see me use a for each statement on a regular. In fact, I don't know how often we're actually going to use arrays in here, because now you guys have all this data structure stuff at your disposal. We're going to be using them, in the form of an array list, for example, or some other type of data structure that's using an array behind the scenes. So, yeah, that's going to happen every once in a while. We'll use an array, but by the majority of cases, we're going to be using array lists, queues, stacks, the data structure stuff that you studied last semester. Okay? But every once in a while, use an array, and that's the basics for how to do it. So in particular, I really don't like 2D arrays. Okay, remember I said last time I don't like for each, do while loops. Okay, the same is true of a 2D array. In fact, I use a class called a matrix, which is supposed to represent a two-dimensional construct that can hold floats. And generally speaking, we call this top left element 1, 1, and this bottom right 1, 2, 3, 4, 5, 1, 2, so 5, row 4, column 5 for the bottom right of this particular one. So you might think, well, let me use the syntax to figure out how to create a 2D array in Java, and you spend time, because I don't talk about it in class, you spend time looking it up online, and you realize there's a bunch of weird stuff that happened with Java arrays. Don't have to do that. There's no reason pretty much to ever use a 2D array structure, whether it's a matrix representation like this or an object array. Okay? There's always another way to do it. In this case, there's some mathematical formulas that you can use. So behind the scenes, I'm going to create a 1D array that's got all those elements in it. And so if you ask me for the 3, 3 element here, okay, so from the user's perspective, I'm letting you specify rows and columns. But behind the scenes, what I'm doing is simply computing, well, if they want index 3, 3, I know the number of rows, I know the number of columns, I can figure out which index in a 1D array that that's supposed to refer to. Okay? So there are weird things in Java that can happen if you try to use the actual 2D array syntax. You can have something called a ragged array, and that's where each row can have a different number of columns. Okay? So there's some additional things you need to worry about if you use a 2D array. So I'm not going to put that on your test. I really don't like using 2D arrays, and you probably covered 3D arrays. Okay? That's way overkill. Okay? In fact, if you were tempted, I don't know if I can try to construct a meaningful example. Let's suppose you were trying to store information about a person. And you have a bunch of people. And here they are, person A, B, C, and D. And they've got a name, they've got a phone number, they've got an address, whatever. So one ridiculous way you could try to store an array of people is to do it as a 2D array, where each row corresponds to an individual, and you've got their name, phone number, address, and all their other stuff. Social security number, all the private information, so you can just hack all their accounts and all that kind of stuff. Okay? What's a better way to do this with a 1D array? Write a class that's got these as the instance variables, and so you collapse each person down into a single item, and you can use a 1D array. Okay? So if you ever find yourself looking up 2D array stuff about Java or C++ for that matter, think about it again. Rethink the problem. Do you really need the 2D array? 99% of the time, the answer is probably no, you really don't need it. Okay? So don't do that. That means you need to design your classes better, so that that's not necessary. Okay. Enumerations. Well, as you remember from C++, that gives you a convenient way to, if a particular item has discrete values, let's suppose there's 5 different values, you can, let's say they're colors. So I got an enum of colors that I want to be red. In fact, let's make it be 3. Red, green, and blue. It's got a distinct set of values that it can take. And so it's certainly going to increase the readability of your code if you give those distinct states a meaningful name, rather than simply using an integer, which is what C++ does behind the scenes. It'll assign red, wherever you use red, if you use an enum in C++, wherever you use that keyword red, it's going to insert a 0. Green's going to be a 1, blue's going to be a 2, or whatever the case may be. In fact, I think you can change those values. I don't remember how. Okay? So that's the idea behind an enum. You've got a discrete set of states that something can be, and you'd rather refer to them with a meaningful name rather than an integer. Okay? So Java uses that same kind of idea, so at least some of this will look fairly familiar. Let's hide more than we need to see now. So I've got an enum, which it's going to be ingredients, and you can see the list of all the ingredients there are. So it's a distinct set of possibilities. We don't have an infinite number of ingredients available. What we've got is 8 different types of ingredients, which is going to be a lot easier for me to debug and figure out what my code's doing if I refer to those ingredients by their names rather than by some integer. Okay? So, in fact, there's a little bit more to discuss here than even that, because Java does treats enums as classes rather than integers like C++. Okay? So there's a little bit of built-in functionality that we can try to get out of using an enum that's just not possible with regular old C++ enums. So let's take a look. So let's stop. Suppose my enum is as simple as that. I think that looks pretty close to what the syntax for C++ is. Let's suppose I want to write a program where I declare a variable to be of that enum type, and I give it one of those values, and I try to print that value out to the screen. Okay, so not much happening. Well, let's at least get this much to work. That's not what I wanted to have happen. Okay, so we declare a variable. We give it the type of the enum, and then I give it one of the values in that class, and I've got this funny syntax which has to do with remember those last lecture, it's really kind of unfortunate that that was the one that got lost, because using that variable static introduces a lot of confusion. And unfortunately, the most likely place where we encounter that keyword is right here at the beginning, because I use random numbers, that requires singletons, which requires static. There's a few other things that I use for the introductory programming stuff that requires that keyword. Okay? Eventually, we're going to be using it less and less and less and less and less. But it's present here in enums as well. Okay, and you are supposed to use enums in your next lab, or one of the labs coming up very soon. Okay, so I have to cover the material. So instead of using an object name, we're using the enum name to set it to be one of those values. Okay, I'll try to explain where the static comes in a little bit later. But as far as we can see here, I don't see that static keyword appearing anywhere. Okay? Well, let's see if we can get this at least to work. In fact, let's make it be bird foot. Or would you guys prefer scorpion?
More like bird foot.
Okay. So we'll go with bird foot, not. I mean, what'd y'all say?
Scorpion.
Scorpion. We'll go with scorpion and not bird foot. Okay, wow, amazing. They printed out scorpion. Okay, but it is kind of bizarre that, unlike just referencing the scorpion value, which works in C++ because enums are just integers, so no fancy syntax is required. But here in Java, there's actually, I've done the absolute minimum stuff to declare that enum class. Okay, so as we'll see in a few minutes, enums are actually classes. So there's a lot more there's an alternative way I could define this that goes into a lot more detail and provides a lot more functionality. Okay? But before we get to that, the next thing I want to do is, so the reason why we had our little arrays discussion a little while ago, is I would like to create an array that lists all the possible values that ingredient type can have. Okay? So maybe they're in another file. Well, suppose that I want to print out to the screen all these values because I'm creating some kind of menu system that you can select one of these from. Okay? In that case, it might be convenient for me to have an array that's smart enough to figure out for me what all the valid values are without me having to hard code those in. Okay? So here we go. What if you want to print out all the allowed values in the enumeration? And of course, we really want to do that. So let's just uncomment that and make sure it works first. And it didn't. Oh, yeah. So I have to not redeclare this thing. Okay, so I'm going to use, I've already declared ingredient type to be ingredient type, so let's not redeclare it down in that, the for each statement. So that's still using a for each statement, and remember that warning that I told you about is valid here. We have to make sure that each element of that array, to use the for each statement successfully and not get a null pointer exception, I have to be certain that the array has all valid values in it. Okay? Well, using it like I've done here, which I'll get to in a second, the statement, that will happen. The array is going to be exactly the correct size to contain all the valid values that the enumeration can take. Okay? Oh. It makes sense that it wants a type there. Let's call this, let's do like that. Okay. So, in fact, I had no errors, I had no null pointer exceptions because this array was created in the type that it was given when I called this special method called values, which all enumerations have. Every time I declare an enumeration, Java already gives it some methods. And one of those methods is this values thing, which creates an array inside the enumeration class, fills in all the valid values that that enumeration can take, fills that array up with those values, and then returns it. So I'm going to have an array with exactly the right size to fit all these possible values in it. And then, of course, my for each statement should work. Okay? If I had another element that had a null in it, I would have gotten an error. Actually, it probably would have just printed null here. Okay? But if I tried to call a method on that thing, I would have gotten a null pointer exception had it been a null. Okay, so that's nice. What else can we do with enumerations? Well, now let's abandon this particular definition. And do we want to keep this stuff? I guess we can comment this stuff out here. And let's come up with a new definition for an enum that tries to do more with the knowing that enums in Java are actually classes. Okay? And then maybe I can come back and try to explain some of this weird syntax that we have to use to access enumerations. I frequently have to look this stuff up. I don't use enumerations all that frequently, so when I do, I forget some of the weird syntax stuff that are required for it, so I got to look it up too.
So enumerations are basically just a different type of class?
Yes. Yes. So they're given a lot of default functionality that didn't even appear up here, but we had a values method. Okay? So Java fills in some stuff when we declare something to be an enum. It says, okay, this is a special type of class. I'm going to plunk down some default methods. Just like all of the classes we write automatically have a toString method. Okay? Even if we don't write one. So there is some filling in that Java does, which we'll spend, lots of time on later in the course to understand exactly how that process is done. But for enums, one of those things is let's automatically give it a values method. Okay? All right, let's make it more sophisticated. So here's another way I can declare that enum of ingredient type. And I still want it to have these particular values, mushroom, fern, frog. But you can see now I've added on a couple of extra parameters. Okay? And both of those things are defined right here below. The first one is going to be a value, and the second one is going to be the string representation of the name, which I probably really didn't need. Okay, so just to do something, I threw that in there. Okay, I could already print out the fact that it's mushroom. We saw that earlier. Okay, but just to give us more to work with, I've given it a value and a name. Okay, which means it might make sense to allow the user to get those values back out, because remember, we always make stuff private. That applies here as well. So we're using encapsulation. I only want to let the user have access to those values through methods that I've written. Okay? So they are allowed, I'm going to let them get those values back out, but I'm not going to let the user change those values except through, well, actually the user can't change them at all, because look what I did with the constructor. So another unfortunate thing about what happens at the beginning of this class is we almost never make our constructors private. But for singleton we need to, and for enums we need to. Okay? So you probably won't see it much more after today's lecture. Those are two very special cases. Now I'm going to let the user get those values back out, but like I said, I don't want them to be able to change them after they've been set in the constructor. Okay? Now, how is it that I'm able to call those constructors here? Does anybody remember the tricky thing about private? Keyword private? Yeah, you're allowed to call stuff that's private if you're within within one of your own methods, or you're in a method of an object of the same class. Okay? So, in this case, here we are inside ingredient type, we can call a constructor. So what am I actually doing here? I'm creating a bunch of default objects. Okay? So essentially, that's what was happening up here. I was creating a bunch of objects of that class and storing them inside that class. Okay? So I'm calling mushroom. I'm providing an index 1 and a string representation. I go through all 8 of those, and actually I tack on an invalid one at the end. Okay? Because sometimes that actually happens. And that's how this private constructor gets called, and that's how those values get set. And then if I need those values out later by anybody who's able to obtain those values, they can always get the index. If they want that representation, they can always get the name, and they can always do this again to print out all the valid values. In fact, let's make sure that still works. I haven't actually tried that. Is there any reason why that wouldn't still work? I don't think so. Okay. So it still did the exact same procedure. It went in here and got these allowed values, created that values array with each one of those placed in it, and then returned it. And then we can print out what those particular things were. Okay? So that stuff still all works with our new definition of the... So we still have all the functionality that we had up here, but now each one of those values can store additional information. Okay? Now this is real simplistic. I didn't really even need the string representation. But you can imagine, hey, if I'm allowed to add all kinds of variables there, then I can make each one of those enum values as complicated as I want. Okay? So they can store all kinds of information. I haven't really needed anything more sophisticated than what you see here, but it could happen. So Java, when they developed the language, they said, well, let's make enums a little bit more powerful and let the user add in features if they want to. So what's really happening up here with this weird syntax for getting the value, where we have to use the enum name, the name of the enum, just like we had to use a class name when we were dealing with static, is because that's what these things really are. We're creating a bunch of objects. When the enum is defined, the user cannot create any new objects. Okay? So we refer to those things, essentially, they're static objects. So we've got that weird keyword coming in again, which makes funny rules for when we want to call methods on stuff that's static. Okay? I can't create any more. I can ask these particular objects for their values and names, but this is the list of the stuff that's going to be created. The user is never going to be able to create any more because the constructor is private. Okay? So I pre-create a bunch of objects, kind of like what we did with singleton. Okay, we created one object. The user ever wanted to ask for it, yeah, we'll give you a reference to it. Just like they're allowed to have references to these things, these predefined objects, but those are the only ones they can ever get to. Okay? And then finally, I've done some trickery here. What I'm trying to do with this section of code here is I want to let the user give me an index, and I'm going to return the predefined object, mushroom, fern, frog, whatever it happens to be, that corresponds to that index. Okay? That's really not something that's generally, when I use enums, I have to go ahead and say that most of the time when I use enums, this is what I need. Okay? Every once in a while, I will need this extra functionality that lets me say, I would like the object associated with index 1 and have mushroom come back. Or I want the object associated with index 3 and get frog back. It's not common that I need that, but every once in a while when I'm using an enum, I want something complicated like that. So let's see if we can figure out how this thing works. So first of all, annoyingly, it's a static method. How do we call, have we already figured out how to call static methods? How do you call static methods?
Class.
Yeah. So we're going to, again, use this ingredient type name. Okay? So now maybe I can explain why that's the case. The user can't create objects. Okay? For singleton or enums, the objects that are created have already been created. They don't have the freedom to do that. So it's going to be hard to use object.method. Okay? So instead, we let them specify the fact that they want to run this method via the name of the class, or in this case, the name of the enum. So I want to run that method, and I expect it to return to me an ingredient type. So we can figure out how to call this thing. Let's call it iType. Okay. I look at the return type and I say, okay, remember if the method returns something, most likely you want to store it in a variable using an assignment statement. Okay? Please don't get into the nasty habit of ignoring the values that get returned, although Java will let you do that. Okay? Assume, even if you don't need it right away, assume that eventually you're going to need it, so set it up when you call that procedure to store the result in a variable. Okay? So to call that method, I use the enum type. And it's called getIngredientType. And I want to get, let's say, index, oh, I don't know, 4. And then I want to print it out. And I guess we don't really need to do this anymore. Okay, so let's make sure that actually works. It gave me bird foot. 1, 2, 3, 4. Okay, so if I ever want to get back an object and I would like to be able to reference its order in this list here to get back a particular one of those objects, then I have to do this special method. Let's see how that works down here. Okay. You give me, I've already built this array. Remember we were using that array before up here. Okay? So I went ahead and called the values method and created an array of the exact correct size to hold all of those objects in it. That way, when the user gives me an index wanting one of those objects to be returned to it, all I have to do is access the associated index from this array. Okay? So I go ahead and just ask for that array right off the bat, and then I have this method that will now allow users to pick out particular enumeration objects by index. Okay? So, like I said, I don't use that frequently. In fact, I don't use this level of complexity that frequently either. Most of the time it's super simple. But I'm pretty sure that in some of your labs you're going to have to do something at least adding on some calling the constructor and adding on some new fields that the user can call get and set methods on. Okay? All right. So, what I want to do next, I guess, is try to spend some more, since we lost the recording on static, and it happens to be one of the more complicated things. Hopefully this one will actually successfully save. Let me focus in on this keyword. It can be used in two places. It can be used on an instance, actually it's not an instance variable. Variable declared outside a method. Okay, did we do that? I used static on a variable declared outside a method. In fact, in this case, it's ingredient types. Okay? And we could have done that here. I could, in enum driver, I could declare a variable to be static, whatever, blah, rational number. Okay? What that does, when you see that, you should think the following thing. Let this word come to mind. It's shared. That means, in fact, let's put it in a more meaningful context than that. Suppose here's my rational number class. And I've got a static variable, rational number, or even, let's make it be an integer. Let's simplify that. Int, my int, is equal to 4. Okay? That static keyword, when you see it declared in front of a variable, think shared. That means it doesn't matter how many rational numbers that I create. Suppose I create 1,000 rational numbers. They all have a variable called myInt that's set to 4. Okay? They don't all have a separate one. They have one that they all share. So if I provide a method that changes myInt's value to be 17, all of the rational numbers that I created are going to see that value now as 17. Yes?
Will they all point to it, or will they all have their own separate value that is 17?
There's going to be a place in memory reserved for that one value that they all access.
Okay.
Okay?
And they all point to it.
If it's a pointer, then I don't know that I really want to say that they point to it. Okay? They all share that value. So it's part of the class definition where we reserve memory for the stuff that's common to all the classes. For example, rational number has some methods. All rational numbers are going. When we write a class and we've got some methods in it, all the rational numbers share those methods. Okay, so that's also shared. That's beyond what I wanted to discuss. But when we define a class, there's some stuff that gets plunked down in memory that's common to everything in that class, and that's where that variable sits. Okay, so to get the answer right on the exam, though, it's shared. In fact, you can call it, let's call it a class level variable. So if I want to change it, so now I'm writing a main method, and suppose I wanted to change that value. Inside main, wherever that is, in fact, to do that I got to make it public, so let's do that. Okay? So in general, we don't want to be able to have our users do what I'm about to do. I want to change that value, and I'm going to change it for all the rational numbers by simply using the class name dot myint equals 17. Okay? Now all the rational numbers, if they access that value, they're all going to see 17. Okay? So if I use it on an object, all the classes are going to have a reference to that same object. Okay, so if I change the contents of the object for one, they're all going to see that object changed. But really, the same rule applies. If you just think in terms of a shared variable or a class level variable, you get the idea of what static's doing when it's used in front of a variable declared outside a method. Okay? I don't believe I've ever used static inside a method. So there's no reason to. Okay? But also remember that visibility modifiers don't apply to variables declared inside methods either. Variables inside methods are local. They get destroyed when the method finishes. They don't need visibility modifiers. Okay. So, 2. What happens when I use static for a method? Like you had to do in lab. In fact, let's go to that exact example, maybe, where we had private, static, we had an array list that contained brass card, it was the shuffle method, and I think I gave you a method that didn't take any parameters. Okay? We used the keyword static on a method. Well, guess what that means? That means that method also has to be shared in a particular sense. This method, I'm not allowed to use instance variables in the method. Remember, the thing that makes all of our objects different is the contents of the instance variables. Okay? So if I use the keyword static, which prevents me from using those variables in a method, you can think of that method as it's going to operate the same no matter what. In fact, okay, so the very fact that I'm not allowed to use instance variables in the method means that a static method can be moved anywhere. I can put it inside a driver class. I can put the, what we're doing brass deck. I can put this method, which is supposed to operate on brass deck stuff, in, I don't know, what's some other class you guys are dealing with? The permutation class. Okay? It has no fixed location because what makes the objects different from one another is their instance variables. So the fact that I'm saying I'm not going to use instance variables means everything's going to be treated the same. So what you have to do in your lab to follow that rule, if you make that procedure static, is you've got to pass in the shuffle deck as a parameter. So you have to make, so here's unshuffled deck, sorry. You pass that in as a parameter, and then you also want to get the shuffle deck out. Well, we're going to return something. We're going to create and build the shuffle deck and return it. Okay? So static methods, what you're actually saying, so if I were going to rephrase this again, so here's one way of looking at it. Not allowed to use instant variables, but there's another way to say that. So there's 1, here's 2. Okay? So everything, so for a static method, everything we need is passed as a parameter. Okay? That's a terrible 2. So either don't use instance variables in here, which essentially means this. Anything I need to do my job, I either already have access to through local variables or got passed to me through the parameter list. Okay? So those are the rules for static.
So why would you make a static method in a class instead of just making it a general method?
Okay, as I was saying, what that actually means is we can move that anywhere. Okay? So the reason why I would still say that it's good design to place this thing in brass deck is because we're actually dealing with a collection of brass cards. Okay? But in reality, we could move it anywhere and call it from anywhere because everything it needs is going to be passed to it anyway. So still, you need to think about the placement of static methods. Okay? And in fact, this could have easily been a non-static method, take that keyword out, directly use the unshuffled deck rather than passing it in, and then creating the shuffle deck, I don't even need to return it anymore. I just set the instance variable to be the thing that I created. So we could have made this thing be void and shuffle with no parameters if we get rid of the static keyword. However, then now it must be in the brass deck class, otherwise it won't have access to the instance variables that it needs to do its job. Okay? Did that answer your question?
Yeah.
Yes?
Doesn't it also change the way you call the method? Like if it's a static method, you have to do class name dot your method.
Correct.
If it's an object, it's your object dot.
That is absolutely correct. Static method, because you're assuming that that method isn't going to be using any objects anyway, you use the class name rather than a particular object. Okay, it does change the way you call it. Okay? All right. I think we're done. Let's make sure this recording worked.